Hey everybody, it's Dr. Gilchrist, and I wanted to record a couple of short little videos to go over how to do things like Pearson's R in the context of Excel for your latest homework assignment, which I am accepting until the 22nd. So last week when we were talking about correlations, I got kind of stuck with coming up with means and standard deviations, because when you plug them into a formula to get z-scores, there's something that I forgot to do that I want to show you today, and it's going to make calculating things in Excel so much easier. So you can see here I've got some fake data from student IDs and then seeing how their exam 1 performance correlates with their final exam performance. So this is fake data here. You can see here we've got the z-scores for exam, we've got the z-scores for the final, and then we've got the z-scores between the two, which will allow us to obtain Pearson's R. So the first thing that we have to do is get the averages and the standard deviations for both of these exam scores. And I apologize for my sniffling. I did, in fact, catch a cold. I'm also on lots of Mucinex so that I'm a little less congested. So apologies in advance for all the sniffling. So what we're going to do is we're going to go ahead and plug in the formula. You can kind of see that I've got it right here, average, and I'm going to go ahead and pick the entire exam 1 data for the average. And you can see that it comes out to 87.8. Now, where I kind of messed up is that I left it there. And it turns out there's a neat little trick that you can do that will basically lock this in to this number every time I call for a mean. So what you're going to need to do is go back to the mean that you obtained, and you're going to right click. And what I want you to do is pick this little item from the drop-down menu that says define name. So I'm going to go ahead and do that. I'm going to go ahead and call this MX. So that lets me know, I might actually make it mean X. So that way you know that it's the mean for that particular value, our X coordinate. So now, if I enter in mean X, that is exactly what I get. Next, we're going to do the exact same thing with the standard deviation. So we go to stdev.s. Remember, we're looking for our sample standard deviation. Again, we are picking exam 1, and we're going to go ahead and get 14.5. And again, to make sure that I call on this appropriately, we're going to go to define name. And I'm going to go ahead and call this S with a capital X. So now I've defined the name, and now I can get the z-scores for exam 1. So here's what I'm going to do. I'm going to call in the first person's exam 1 score. So that's B2. I'm going to go ahead and put that in the parentheses just to make sure. Minus mean X. So you can see it called it up right there as I defined it. So we call that in, and we're going to divide that by S of X, which is also called up. And when we do that and hit enter, the way that this is set up, it fills in all of the missing values, but what you could also do is a Control-C and a Control-V, and you will obtain the exact same values. So now that we've defined that name, notice that we don't get all of those errors, because what was basically happening, because I did not define the name and I didn't call it in, it was going to the next item down, which was empty, and thus we got a divisor over 0. Now we're going to have to do the same thing with the mean for Y. So we're going to go ahead and pick our average once again, and we're going to select this subset. And when we do, we get 85.8, and we get our standard deviation. We'll go ahead and get that as well. We're going to scroll and then hit enter, and we get a standard deviation of 9. And again, we need to define these names. So we define the name. We're going to call this mean Y, so our Y coordinate, and we're going to call this lowercase uppercase y. So now I can do the exact same thing that I did previously. So we go to equal, we have C2 this time. Oh, got those parentheses. C2, oh, C2 minus mean of y. So call in mean of y. And we're going to divide that over S of y. There you go. We hit enter, and you can see we get all of the z-scores for that. If you don't believe me, hit a Control-C, select all of these, Control-V. They're exactly the same. Now, all we have to do is multiply the z-score for x times the z-score for y. So we pick E2 times F2. There we go. Now we have all of our z-scores. So we're going to add all of these together. So our sum is all of these. We add that. N minus 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. N minus 1 equals 8. If you want a formula for this, you can do count of these. Oh, nope. Okay. We have count. Oh, no. No. Okay, let's try that one more time. Equals count. So we're going to count all of these minus 1, and that leaves us with 8. So now we have our correlation coefficient. We take this divided by this, and we obtain a Pearson's R of about 0.576. So this is a really easy way to do this in Excel. Again, make sure that you're going to that define name formula so that when you plug in these formulas, notice that as we kind of look in this formula bar, notice that, oh, B2, B3, B4, B5, B6, 7, 8, 9, and 10. So notice that nothing else changes but the exam 1 value. So if you have any questions on this, let me know, but hopefully this is an easier way for you to figure out a correlation coefficient in Excel. And if you were kind of curious if this is the correct value, what we do our Correl, and we'll just check and make sure we did it right. And look at that, we did. So hopefully this helps you out. I will see you all next time. Bye, everybody.